Hey, Griffin.
Hi.
How are you tonight?
Good, how are you?
Good. It's a little weird it being daylight out at 7, but
Yeah, I know, it's strange.
love it. It's like going from winter to summer all at once.
Yeah.
So what are we doing tonight?
We just got more trigonomic functions. We got double angle formulas, power reducing formulas, and half angle formulas.
Okay.
So a few problems. Sine of 4x equals negative sine 2x, or negative 2 sine 2x.
Okay. And we're just supposed to prove these are the same thing?
Yeah.
Or are we supposed to solve for x? This is just verifying an identity?
Actually, no. Find the exact solutions of the equation from 0 to 2 pi.
Okay. Thinking for a moment. Let's see. We use the double angle formula. Now let's just play around here. If I make this 2 sine of 2x cosine of 2x, might be a place to start. Then I've got minus 2 sine of 2x. Well, I can certainly divide both sides by 2. Now, there's a danger in dividing both sides by 2x. And that is, or by the sine of 2x. So let's not do that. Let's add sine of 2x to both sides. So we have sine of 2x cosine of 2x plus sine of 2x equals 0. And now what can we do?
Now.
Factor out. Usually the solution to these things involves factoring at some point.
Oh, right.
Now, so either that can be 0 or that can be 0. Well, what does it take for this to be 0?
I'm not sure.
Well, if we look at the sine curve, the only way it can be 0 is there, there, and there. Well, so this happens when x equals 0 or pi, but this whole thing would have to equal pi. So x would actually be pi over 2. And then again when it's pi. And in fact, when it's 3 pi over 2. If you multiply that by 2, you get 3 pi, and that's also equal to 0. And it's inside of our unit circle. So those are the 4 solutions that produces. Now, let's let's solve this one. Cosine of 2x equals minus 1. There's a couple of ways to do this. Let's talk about this problem. We have x going from 0 to 2 pi. So let's talk about the domain of 2x. What is the domain of 2x?
2?
0 to 4 pi.
Oh, right.
In other words, we would multiply everything by 2, so the domain of 2x would still be 0 on the low end, but on the upper end it's 4 pi. Now, not everybody's going to teach you this method of doing these. I just happen to be fond of it, and I'll show you why here in a moment. So now we are going to take the inverse cosine of both sides. So 2x equals the inverse cosine of minus 1. Well, where is the cosine equal to minus 1? Pi. But that's only in from 0 to 2 pi. If I go from 0 to 4 pi, well then it clearly is equal to minus 1 again at 3 pi. And now I'm ready to figure out my answer by dividing both sides by 2. So solving for x gets me pi over 2 and 3 pi over 2, both of which are inside my original domain. So these two answers, along with those 4 answers, see we have some overlap there. So actually these 4 answers cover both ends of it. Those 4 solutions right there.
All right.
But that's the way you do it when you have, like, if they were to say solve this, sine of 4 theta equals 1/2. Well, you solve for 4 theta, all of the answers, but the thing is if theta goes from 0 to 2 pi, 4 theta goes from 0 to 8 pi. So when you solve for all the answers of 4 theta, you go all the way out to 8 pi, then you divide each one by 4, putting theta back in the unit circle.
All right. Sine 2x plus cosine 2x, all of that squared, equals 1. And same thing, just solve.
Okay.
Yes.
Well, let's square it.
Okay.
What do we get?
Sine 2x squared.
That's how you write it. In other words, there's a difference between this. That is not equal to this.
Okay.
It is equal to sine x quantity squared. So we get sine squared 2x plus 2 sine 2x cosine 2x plus cosine squared 2x equals 1. Right?
Yep.
What is this plus that equal to?
Sine squared 2x cosine plus
That's equal to 1. Sine squared plus cosine squared is always equal to 1 no matter what the angle is. In this case, the angle is just 2x.
Oh, okay.
So I can replace this and this with 1. And now I can erase that and make this whole thing equal to 0. And now I can divide both sides by 2, and I have this. And so now, what's the solution? What's my next step of logic?
Can you just convert it back into... Wait, never mind.
Don't need to. In other words, now solve it like it's an algebraic equation. Set that equal to 0 and set that equal to 0.
Okay.
So we have the sine of 2x equals 0. Where does that occur? And again, this is a case where we have to go out to 4 pi.
Mm-hmm.
Well, it occurs there, 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 and there. Well, actually, that one's at not that final one. So this is pi, 2 pi, 3 pi, and 0. Those 4 spots. So 2x is equal to 0, pi, 2 pi, and 3 pi. So x is equal to 0, pi over 2, pi, and 3 pi over 2. That's just for that part. Now let's set cosine of 2x equals 0. And let's draw the cosine curve. That's why you really want these curves memorized. I think the biggest reason is to find these quadrangle problems. So this is at pi over 2, 3 pi over 2, 5 pi over 2, and 7 pi over 2.
Mm-hmm.
When I divide each of these by 2 to solve for x, I'm going to have pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. You saw what I did there?
Mm-hmm.
All 8 of our answers are different and all within 0 to 2 pi.
All right.
The biggest mistake people make when they do these is they apply the domain to 2x, so they would only get these 2 answers. Dividing by 2, you would only get those 2 answers. We would lose those 2 and those 2 if we did it without expanding the domain.
Mm-hmm. All right. This one says, use a double angle formula to rewrite the expression.
Okay.
It's 6 sine x cosine x.
So, So if I multiply both sides by 3, I presume that's what they're looking for.
Yeah, it seems like it. Alright. Let's see. This one is using the power reducing formulas.
Okay. May have to look those up. Hold on a second. Let me look those up. Not very many of my students use the power reducing formulas. In fact, I think I actually have to go to my other book. Power reducing. In fact, I have to look it up in the index. Wow. Couldn't give me the, hold on, product to sum. Have you had product to sum to product?
I don't think so.
Okay, I think I know what they mean by the power reducing formulas. Go ahead and give me the problem.
Cosine to the 4th x.
And we want to reduce that down. Okay, I know what this is. Cosine, first of all, the reducing formula is 1 minus cosine of 2x over 2. Which one? Is that the one for sine or cosine?
That's sine. Cosine is just plus.
With a plus, okay. So, since cosine squared is, or cosine to the 4th is cosine squared times cosine squared, then that's equal to cosine to the 4th. And how far down does he want you to reduce it?
It says rewrite the expression in terms of the first power of the cosine.
Okay. So alright. So if we square this, what do we get here? We got 1/2 squared, which is 1/4, plus 2 times 1/2 times cosine of 2x plus cosine squared of 2x over 4. The only one we have to keep going on is that. So that is equal to 1 plus cosine of 4x all over 8. Correct?
How did you get there?
Well, let's see. We had cosine squared x equal 1 plus cosine 2x over 2. So I took the 1/4 out. That's going to turn into 8 when combined with the 2. So the only thing I had to do was change the cosine squared of 2x. And instead of this being 2x, it becomes 4x then.
Oh, okay.
Okay? So your final answer should be that.
Okay.
And that can be It can be simplified a little bit, but not a lot. I mean, we could certainly simplify. We could pull a 1/8 out of there and combine it with the 1/4. And I suppose we should do that. What is that? That's 3/8 plus cosine of 2x plus cosine of 4x over 8. So that is down to a single power of cosine. And now, as long as they didn't say a single power of cosine of x, and I don't think they did. When you read it, it seemed like it was, you could get your answer down to cosine of 4x. You'd be all right.
Yeah, this is right.
Okay. Do you have answers on these?
Yeah, I'll check that.
Well, that's okay. Yeah. All right. The power reducing formulas are so valuable when you get to calculus.
Mm-hmm.
The reason is you can't integrate that, but you can easily integrate this.
Mm-hmm.
I can integrate that piece of cake. That is really complicated. So whenever you have trig function squared and you're trying to integrate it, you're going to use those power reducing formulas.
All right.
They're essentially the opposite of the double angle or the half angle formula.
Mm-hmm.
Or that's where they come from.
So here we're using the half angle formula.
Okay.
And it just says to simplify the expression.
Okay.
It's square root of 1 minus cosine 6x over 2.
Well,
And that's all square root.
And that's what?
It's all square rooted?
Oh, including the 2.
Yeah.
Okay. So what do we know about that? That is equal to the square root of 1 minus 6. And that reduction formula, hold on. So if I know that cosine squared of x equals this 1 minus cosine of 2x over 2, right?
Yeah.
That would make cosine squared of 3x equal to 1 plus cosine of 6x over 2.
Mm-hmm.
Since we have a minus sign, we're talking sine instead of cosine. Sorry. It was a minus sign, wasn't it?
Yeah.
Okay. So if I take the square root of both sides, I have the sine of 3x on the left. That's what it reduces to.
Oh, okay.
Now, I didn't get that very elegantly. I'm trying to figure out how. Well, you certainly have to recognize that it's the half angle, which is where you get the power reduction from.
Mm-hmm.
Okay.
All right. So let's find all solutions of the equation in the interval 0 to 2 pi. All right, sine of x over 2 plus cosine x equals 0.
What's the half angle formula for sine?
Plus and minus root 1 minus cosine x over 2.
Okay, the way I see a solution coming is to square both sides and then treat it as a quadratic.
Okay.
Now let's see what happens when we do that. We're going to want to make sure we check our answers because this plus or minus bothers me a little bit. So first of all, let's take this to the other side. Now square both sides, which takes care of the square root 1 minus cosine x over 2 equals, wow, really takes care of it. And now multiply by 2. Take everything on one side, so I have 2 cosine squared of x plus cosine of x minus 1 equals 0. That should factor nicely. Cosine x equals 1/2, or cosine x equals minus 1. Where do these occur?
1/2 is pi over 3. And
Which quadrant?
5 pi over 3.
Uh-huh. And where does this one occur?
Pi.
Uh-huh. So there's your 3 answers. Normally you get 4, but whenever you have a quadrangle, whenever it's 1 or minus 1, there's only one answer in the unit circle.
Alright.
Alright.
And the rest of them are pretty much the exact same as that. So.
Okay. Cool. Alright. Sounds good. Griffin, you have a good night.
You too. Thank you.
Talk to you next time. Bye-bye.
Bye.